Success is graduates who get employed. It's a thriving, curiosity-driven community with teachers wanting to teach and students wanting to learn.
So it's the vibe.
It's a vibe.
Hello, and welcome to the Entrepreneurship podcast series. In this episode, Todd Davey speaks with Judy Raper, former CEO and Dean of ASU London, about what it really takes to design interdisciplinary, industry-connected education from the ground up. Drawing on her experience launching a brand new university model, Judy reflects on how project-based learning, curiosity-driven education, and real-world challenges can reshape how engineers and universities are formed.
I am Todd Davey. I am an Associate Professor of Entrepreneurship at the UIIN Telecom Business School, as well as being an Associate Partner at UIIN. But our very special guest today, Judy Raper, she is previously the CEO and Dean of ASU London. Formerly, it was called TEDdy. It's a new collaboration between the University of New South Wales, Arizona State, and King's College London. Judy, welcome.
Thank you. I'm glad to be here. Yeah.
Now, I'm going to give a little bit of an introduction to you because you are a distinguished chemical engineer with over 40 years of experience in air, water, pollution control, and particle technology. As I mentioned, she was formerly the Dean and CEO of ASU London, but she's also held a number of different senior leadership roles across academia, including a Deputy Vice Chancellor role at the University of Wollongong, the Dean of Engineering at University of Sydney, and she has also won the Member of the Order of Australia in recognition of her contribution to engineering, research and innovation. So really looking forward to jumping into some topics today. I just wanted to ask a little bit about the model and just describe what TEDdy is to us. It's now called ASU London, but perhaps you could just give the description of how that came about, maybe a little bit about its origin and development.
So the three universities, ASU in Phoenix, University of New South Wales in Sydney, and King's College London, were part of the Plus Alliance, which was a research alliance. And it was a top-heavy, that the vice chancellors knew each other and wanted to form a research alliance. And they had been going for a few years. And then they decided that they wanted to do something significant in undergraduate education. And so it came about that in England, there was a lot of political issues. This was before Brexit and COVID. So it was quite a few years before, and there was a lot of political pressure to start new universities that were different. And the engineering education in the UK was seen as not as advanced or modern or industry focused as that in the US and Australia. And they thought that it would be, the vision was to create a new engineering school that created globally focused and socially aware engineers. So take the blinkers off the engineer. And by doing that, we were going to attract diverse students. So diversity was important as well, as engineers are traditionally male and white. And so that was the important part of it. And they wanted to have something that was industry linked, a lot of industry led projects as a focal point of the whole course. And so that was the general vision before I was hired. And so someone rang me up and said, they knew that I was probably coming to the end of my time. I'd been Deputy Vice Chancellor Research for 10 years. Would I take this on for 6 months? And I was really excited by it. I said, no, I'll take it on, but not for 6 months. I want to see some graduates. I want to see it through. And it was really exciting for me because it was an opportunity to take my background in engineering education, which I'm passionate about, but also innovation and starting up a new university is like a dream job for a lot of people. But I had to put that vision into practice. So the way we executed that vision was to say the projects have to be responsible for the learning outcomes, not just, as in other engineering schools, generic skills. So it's you learn thermodynamics and then you do a project that just teaches you how to be a good leader or a collaborator or write reports. And that's not what we wanted at all. The projects had to be front and center of the learning. And so that's what they do.
Well, that's a great segue into maybe a question that I'd like to explore a little bit, was that what were the problems that you were seeing in engineering education that this model addressed? What was the sort of things that you were witnessing that you thought you needed to address with this specific model?
So for many years, industry have complained that engineers come out very technically skilled, but not very socially aware. They don't know the context of what they're doing, and they not even financial, but not a social context, and that they need to learn all that in the workplace. So we wanted to, and as I said, it's taking the blinkers off engineers. So they had to be technically skilled, but that's what was happening. And we heard that from industry people. We've heard that for years. And so I was trying to address that challenge. We had a workshop at the beginning when we were trying to develop the curriculum with some industry people. And we asked them the question, how much of your engineering knowledge that you learned in university do you use at all, day to day or monthly or yearly? And it was about 10%. So it was really, we are teaching them too much. We are teaching them to be like us. And like us means researchers, deep researchers in engineering. We were teaching differential equations. It was all maths, basically. And we were examining that as well. So you're not examining what an engineer needs to do when they go out and work.
And I guess having a clean slate for university, it's an exciting prospect. And I guess that's what you were alluding to right at the start. And so what you decided to do was create a project-based learning environment where there were challenges. And maybe you could just elaborate on how that worked and how you embedded that at the heart of what you did.
So we had every year, we focused on a global challenge. And so the first year it was zero carbon. And we said the first year projects have to be related to zero carbon in some way. So we had to design modules. But the reason we had to have modules is because of the accreditation and the degree awarding house. That's a different issue that we'll get to. But we had every module. So they learned thermodynamics, materials, fluid flow, heat transfer through taking apart a energy recovery unit that was part of our new building, our new sustainable building, and then putting it back together again. And then in their next module, they had to design part of that unit and show how it worked and show improvements. So that type of project where they're learning their engineering technical skills and theory, but it's through making something. And the whole idea is that you learn with your hands. Through your hands, you're doing something. Like the craftsman, it's a very different sort of skill. So that's how we said it. And everything had to be a project. And it might have been a computer project, like a program or something. It didn't have to be a physical object. One year we had, for the same modules for first year students, they came straight into first year, they had to build a robotic vacuum cleaner. So they had to first take apart a robotic vacuum cleaner to learn heat transfer, materials, energy, balances, fluid flow. Then the next module, they had to design a robotic vacuum cleaner that could be repaired, because the theme for that year was right to repair. So we had these cardboard and 3D printed vacuum cleaners running around the campus that first year students had built that picked up dust and didn't run into things. It was pretty impressive. And then you could repair them as well.
What I love about that is that it's curiosity-based learning, because you put them in a situation where they're exploring something, and in that exploration, they've got questions because something's not working or they can't understand how something's working. And so what you're describing is, to me, sounds like it's like a keystone project that runs through their entire study, and all of the modules are sort of built around that. Have I understood that correctly?
That's what I'd like to have. That's not what we ended up with. We ended up with different projects that it went over 2 modules. So it went over maybe two terms. We had terms, 2 terms, and they continued on from the previous one. But then there was a different project for the next module. But what I would like to have is a keystone project. And this is where I'm thinking about the future of universities. If you had a keystone project, which was an affordable house, build an affordable house, and you start at the beginning in first year and you finished it by the final year, but you've had not just engineers and architects, you've had scientists in there, you've had social scientists looking at the policies, you've had business students, you've had geographers, so there's art students, there's an array of disciplines that could be used with one project, but all supported by theoretical modules of their own, from their own disciplines, and assessed by people with expertise in their own disciplines as well. Yeah,
brilliant. Love the concept. And I guess it comes back to something that I've read that you encapsulated in that expression, which is how TEDdy was designed to capture just-in-time learning as opposed to just-in-case learning. And I thought that was fascinating. So maybe you could explain that a little bit more.
Yeah, so instead of having a whole semester of thermodynamics or a whole semester of fluid mechanics, we had modules, which was like a lot of online modules are like this now, where students can access them whenever they want. But they access the modules when they needed it to make whatever they're going to make. So the curiosity of making a robot or a robotic vacuum cleaner, they realized that they needed some thermodynamics or some materials in there to know how to make it. And that those modules were available to them at all times, and they could go back to them. And theoretically, after they graduate, they could go back to them as well. So we said lectures were banned. This was quite contentious. And people still stood in front of the classrooms when we had tutorials and things. And, we had master classes, but still it was the whole point is that we didn't have any weekly lectures where you're doing, just in case, the series of 14 lectures on one topic, just in case you might need it at some time.
Yeah, fantastic. And I thought there were some other elements that were really interesting as well, and maybe you could elaborate on that, is how you used makerspaces, and then also how did you foster self-ownership of learning in the students? So
the makerspaces were engineering projects require stuff, but tinkering and making things is part of this curiosity-based learning. So we had to use the makerspaces in order to make some of the projects, but also we encouraged the students to use them for their own private work too. And this is, as the campus grows, I don't know how well that's going to work, but as best you could, if you've got small classes and you've got reasonable facilities, you can open late and that sort of thing. If students are making things for their coursework, but also making things for themselves, they're learning even more as they go along. And the assessment, did you say the assessment was next? How we assessed? Or
it was a self-ownership piece.
Oh, the self-ownership.
How did you foster that? Yeah.
Yeah, I guess assessment partly it was who we were recruited, and I know we couldn't have a choice really. We didn't have enough students, so that was part of the challenge, but we were still particular about who we recruited because we knew that students would not get along if they weren't responsible for their own learning. So recruitment was an interview. Every student was interviewed, and the interview, there was a sort of a self-assessment test that we checked that they were suitable. So that's part of it, but also the assessment, the peer pressure, and the culture of the place. And that's the only way we could do it, I think. Not every student was ideal and was responsible. Of course, we had weaker students, but
I mean, they're students, right?
Yeah, that's right.
I just wanted to understand a little bit more also about how you integrated and collaborated with industry as part of this program.
So it wasn't like industry sponsors a research project. For the projects, we had industry mentors, and they were from different industries and probably different sort of positions and different disciplines within the industries too. So the robotic vacuum cleaner, we had vacuum cleaners with a sponsorship. So we had them come and show the students what they do, donate vacuum cleaners that the students could take apart. And they were involved, like probably there'd be one person assigned or one or two people, and they'd come every week or every other week to discuss things with the students and to mentor them. Then we might have had a mentor from some of the government agencies that regulate products and things like that. So we had a variety of different mentors with different backgrounds themselves. And for them, they got access to the students, but they also got access to each other.
So in collaborating with you, they also got to know other innovation-focused companies.
That's right.
And then also you said access to the students. Was there the ability for them to identify talent that they could recruit or? Yeah,
absolutely. And and also projects. So I think we had a cycling company that they had to sign NDAs and stuff. So they were doing cutting edge projects with different companies as well. So one of the things we used as a sort of sandpit for testing these projects was a summer school. So every year we had a summer school, and we did that. The summer school was run with a series of, it started online. We went through COVID. So it was started even before we had a curriculum. And we said, we're doing this summer school. And one of them was designing a space for dementia patients, or a space or equipment for dementia patients. And so we had people from Dementia Australia or Dementia UK. We had some dementia patients that were part of the group, and they all delivered things to the students online, and then they mentored them as well in their group. So that was and then we used that summer school as a sandpit for projects that we were going to use in the curriculum.
The UIIN Conference 2026, where universities, industry, and innovators meet to shape the future. Join us in Stockholm for 3 days of insight, inspiration, and impact. Hear from global thought leaders, expand your network, and be part of the conversations driving collaboration forward. Submit your abstract and secure your place now at uiin.org/conference.
Okay, great. That I can see the way that would feed in. But I guess we've talked about some really adventurous stuff for your typical universities, and that also creates its own challenges. So perhaps you could just step us through when approaching creating essentially it's a flipped classroom, but it's also having a project-based learning. There's going to be some challenges in a university context. So perhaps you could elaborate on those.
In a university context, the problem we had was we're a startup university. So we thought that on a university context, the challenges wouldn't be that much because you could design the systems based on this. But we had to get accreditation. So we had to get, apart from engineering accreditation, that was not so bad, but the degree awarding powers, you had to set up your university the same way that every other university set up so you could get degree awarding powers. That was a real challenge because you couldn't describe your program, all the forms and everything you fill out as just designed in a similar way to every other university. So that was difficult. We had to have units of study or modules. We had to have learning outcomes. We had to have everything that everybody else has. And it had to be structured on the credit points that the degree offers of students could understand. So that makes it difficult. And I don't know what the solution to that is, but it's maybe, I guess I've talked about this with colleagues sometimes. If you could get enough industry support that maybe you don't need degree awarding power. So this is an apprenticeship, but you're going to get a better degree than you would get in an engineering school, in another school. But that's a whole culture change.
No, that's something I've also witnessed in my own experience is the limitations of accreditation and need to design it in a certain way because it forces you into structuring it in a traditional university manner. Many lessons you would have learned from this, I can imagine. So perhaps you could elaborate on that.
So that was one of the bureaucracies is hard to beat and somehow overcoming that. The other big lesson was that the culture is extremely hard to change. And even though we had fantastic staff and they were all champions of project-based learning, it was still difficult for them to do something completely different. And it was always reverting back to the easier option of, let's just do it the way we used to do, or let's just have the modules the way we used to do it. And so the lesson I learned was if you then be bold and don't give in to people, go with your gut, but then say we're reverting back to our vision. So whatever they say, is that our vision to have lectures or whatever? No, it's not. So it's this constant reverting back to the vision, I think.
Yeah, that demands pretty strong leadership, I can imagine, because when you're dealing with some of the challenges around accreditation, and then you've got staff who you hired on the basis of the fact that, hey, this is our vision, even they, in uncertainty, want to revert back to what they know. I can imagine that is challenging.
Very rewarding. Like we're seeing the graduates. So this first lot of students, there were 24 students, and of those, I think about 12 got bachelor's degrees and about 5 got master's degrees. So they've all graduated now. Not the rest didn't. That was not bad. But half those students would not have gone to university if we didn't exist. So they were really diverse. A lot of people on the spectrum, 45% female, like really diverse, but also just students who lacked confidence, students who didn't perform well at school because it was COVID and lots of things. But some of them thrived. It's wonderful.
And I guess that also feeds into what did success look like for you as part of this vision? What were you trying to achieve?
First of all, financial sustainability is one thing. So that was always a cloud on our horizon. But success is graduates who get employed, but it's a thriving, curiosity-driven community with teachers wanting to teach and students wanting to learn.
So it's the vibe.
Yeah, it's a vibe.
No, I can imagine there's some challenges with the financial context, but what I wanted to do is I wanted to step back now because you've got years of experience in this game. You've seen universities from all different perspectives. I wanted to understand a little bit more about having had that experience. How could that be picked up and used by other universities? Does this have potential to be, you mentioned an example of a cross-disciplinary, not just focused on engineering. Could it be used in, for example, an approach to research? And perhaps you've got a few ideas around that.
Yeah, so research would be easier. So research, I think, it's great, but always remembering that you have to have deep researchers in their disciplines participating in this. So in Wollongong, we had a Global Challenges program for research where there was a carrot, so there was some money, some seed money, not much, but it was a prestigious thing to get. You had to have researchers from 3 different faculties, and there were only 5 faculties across the university. So across two-thirds of the university, you had to have researchers. And they came up with things like 3D printed microtonal flute. So you had to be an expert at 3D printing, you had to be acoustic engineering expert, and you had to be musician or music composer to have this thing. And they came up with the flutes and they designed them, and we had a concert with the flutes, and it's really interesting. Another one was a surfboard with 3D printed fins, printed for individual surfers. And I think that's gone into a company, and they found out that they didn't need to be individual. You could just 3D print a few varieties of fins, and that made the surfing experience so much better or something. I don't know, I'm not a surfer, but that's what they said. And so you had to have materials.
It is useful, I can tell you.
Yeah.
I'm particularly excited by this one.
3D printing expert. So the chemist who led this is a surfer, but he's a chemist. He's a 3D printing expert, materials expert. So you had to have the human geographers were interested in it, the business people as well. So that was pretty exciting. So that works as long as you have good researchers on each of the disciplines. And that's what you have to make sure people don't give up their research depth, but use it to make a better product.
But I can imagine in that context, though, that just putting a normal researcher in a room with people and say, hey, collaborators, is going to be challenging. What would we need to do at universities to make a research model that looks like this work?
Well, I think you'd need to mix up the disciplines. Don't have all the engineers in one room or one building. Mix them up. Have departments that contain philosophers and scientists in the same department or something like that. You could mix up the whole structure and it would help. Of course, you need the research expertise. You need some centres of excellence and stuff in research. But in most universities, you've only got 2 or 3 of those, or maybe in the big universities you've got 10. But the majority of research is Me Too research. So get your depth in one of those centres and then move on to, in the department, you're mixed with a whole lot of people. I don't know if it'll work, but that's something I'd like to see.
Well, speaking of that, maybe you could give some advice. If there's somebody listening to this and they think they want to replicate something about this, so whether it's the project-based learning element, whether it's getting a specific challenge, or just throwing a device into the room and saying, hey, look, figure this out and we'll build some education around it. What advice would you give?
I guess it's very hard in a big university, I understand that, but you could take champions. It has to be incentivized, so that it has to be an investment. There's no doubt that it's resource intensive, much more rewarding, better results, it's innovative. You have to invest. And so providing some incentive and some investment for some champions to get together from different disciplines and maybe live together and have a summer school where they could work on something like this. Maybe the summer school is a sandpit idea for big universities, where they could work on this and do it together. And the other thing is, I think universities need to be bold and innovative in what they do as part of their operation. So they have to lead by example. If you're going to have a 100-year-old system that worked very well, I agree, and you've got a great reputation and everything, high rankings, but the 100-year-old system, you have to be prepared to throw that away at some stage and do things differently.
I think sometimes that is the thing that really holds back leaders at universities, is obviously the historic context. As much as what you described earlier, which is that even those that are inclined to adopt this model, at some point they get a bit insecure and want to do a U-turn and go back to what they know. So just for the listeners, a lot of this conversation that we're having today comes from the Future Universities Thought Book contribution that Judy Raper wrote. So feel free to refer to that. Last thing now, Judy, I was just wondering if you could perhaps give us one takeaway or one wish that you would like everybody to walk away with. What is it that you would like them to be thinking about as a result of this conversation?
I think the one thing is really to be bold and don't give in to people wanting to revert back to old ways. Just go for it. Just try it. Even if it's a pilot project or something, just try and do some things a bit differently. Be open-minded to do something a little bit differently.
I think that's a great way to finish. Thank you very much, Judy Raper. Really appreciate your time today. Love the conversation. For the community, we have the upcoming UIIN conference. That's this year in Stockholm in Sweden, which is a fabulous location. That'll be the 15th to the 17th of June. We also have a series of training programs that are going on at the same time. Navigating partnership ecosystems that will run in March. We have developing entrepreneurial education, which will run in April, as well as initiating partnerships, which will run in May. Now, I mentioned the Future University Thought Book, which is something that we have put together last year. And so that's fresh off the press, and Judy Raper was certainly a big part of that. So again, thank you, Judy. Really appreciate the time. Thanks for the insights you've provided, and all the best for your rest of your day.
Thank you. My pleasure. All the best.
Thank you for listening to today's discussion. Follow UIIN on LinkedIn, and if you're enjoying our podcast, make sure to subscribe, rate, and review in your podcast platform of choice to help other people find this content too.